All right, students, you have a solutions, suspensions, and colloids lab that you need to work on. And because of Rona, you guys can't exactly work in groups. So we had to rethink how this is actually going to happen. So I'm recording a lot of the lab for you so you guys can take a look at it and figure out what's going on. But I want to draw your attention to the very top of the lab. In the section that says theory, it spells out how you can actually identify what is a solution, what is a colloid, and what is a suspension. Essentially, it's saying if it doesn't show the Tyndall effect, that means it's got to be a solution. It's mixed on a molecular level. If it does show the Tyndall effect, then it's either a colloid or a suspension. Well, how can you tell the difference between a colloid and a suspension? The suspension will settle out over time, and the colloid will not. So that's one of the ways to tell between a colloid and a suspension. And I'm going to give you guys some clues as we go along. But one of the first things that you're supposed to do is you are supposed to observe each one of the mixtures, and you need to write down an observation or the appearance or what it looks like. So we're going to go one by one through each one of these things, and then we're going to see if they show the Tyndall effect. So let's go ahead and give this a try. First off, I believe is the sugar water. So the sugar water is right here, and you can take a look. I should probably have a white background behind this or something like that, but take a look at the sugar water and make some, I don't know, tell me what you think about the appearance of that. I have the lights off so the Tyndall effect can be seen a little bit easier. So let's go ahead and go one by one and take a look at the Tyndall effect on each one of these mixtures. This is the sugar water, and I'm going to go ahead and shine a laser through here. Can you see the laser beam through the water? Can you see the laser beam through the water? I got to be honest, it looks like you can see the laser beam through the water, but sugar water should not have a laser beam through here. Do you know why it does? It's also the anti-caking mixture. For this one, I want you to go ahead and put solution. It seems like it's the wrong answer because it's showing the Tyndall effect, but it's only showing the Tyndall effect because the sugar has anti-caking stuff in it. The next one should be starch and water. So let me get the starch and water for you over here. Here's the starch and water. What can you note about its appearance? By the way, one thing that you should note is I have not stirred this for a long time. I have not stirred it for 24 hours, in fact. So this is the starch and water. It has been unstirred for 24 hours. That's going to give you a clue as to what it is. This next one is the starch in the water. Let's see if this shows the Tyndall effect. Can you see a laser beam in there? Is it scattering light? You tell me, can you see the Tyndall effect in here? Is the laser beam scattering light? This next one here is clay and water. This is clay and water. There's a spoon in here. There's clay and water. And the clay and water, this has been stirred recently. A big hint for this one is if I do not stir it, the particles will settle out over time, but we just don't have time to let it settle out. So that's one key thing for you to know about this is the clay and water, and it has been stirred recently because if you leave it unstirred, it will settle out. This next one is the clay and the water. Is it scattering light? I mean, to be honest, it doesn't look like it's even going through. So if it's not going through, we can be 100% sure that it is not a solution. That much we can be sure of. It's not a solution. So you tell me what you think this should be. This is the clay and the water. The next one is food coloring and water. Here's our food coloring and water. It has not been stirred for a while. And since it has not been stirred, make some observations. What do you think about this one? We'll do the Tyndall effect next. But here is the water and food coloring. Let's go to the food coloring in the water. The food coloring in the water. Can you see the laser beam in the food coloring in the water? I mean, sure, we can see a laser beam, but can you see it through the food coloring in the water? So that should give you a clue as to whether this is a solution or whether it is a colloid or whether it is a suspension. Next, here's the salt water, the salt in the water. One thing that's kind of difficult about this one, it's misleading because the salt that you can buy at the store, this salt right here, it's actually free-flowing salt. So it's actually got another ingredient in it that helps it flow easily. Otherwise, it would start to cake up in here. That ingredient that's in the salt actually makes this cloudy. Salt water itself should be uncloudy. It should be completely clear. So when it comes to your appearance or observations for the salt water, this does not show it quite right, but it should be completely and 100% clear. Kind of like ocean water, except without the pollution and stuff like that. So this should be completely clear. This should be the salt water. Let's go to the salt water now. I already told you that the salt water here should be a solution, but because of the anti-caking stuff that's found inside the salt, we can see the laser beam quite clearly in here. So this should be a solution, but it's not a solution because of that stuff in there. And this looks a lot like it could be a suspension. However, it's not supposed to be a suspension, so I want you to write solution for this one. Here's the cooking oil. The cooking oil is next. Please note its appearance. Does it look like it have particles in it? No particles in it? Does it look like it's a mixture? Not a mixture? I'll let you guys decide, but here's the cooking oil. Tell me what you think about the cooking oil. Let's go to the cooking oil. The cooking oil is also a mixture. We're going to shine our laser beam through the cooking oil. Can you see the laser beam in the cooking oil? If you can see a laser beam in there, remember you might have to go up to the top of the page to find out what that means, but that's going to help you out a little bit. Next we have the gelatin. This gelatin has not been stirred for a while, and notice what happens when I do stir this. So let's give this a little bit of a whirl. So what's going on here with this gelatin? One thing that I should say is with this gelatin that if we were to cool it, it would turn into a solid, of course, like Jello, semi-solid. And when it is in its semi-solid form, nothing settles out. So let's pretend that here, even though something here has settled, let's pretend it's its semi-solid form, and we have cooled it to the point where it's Jello, and it doesn't settle out. If it doesn't settle out, that should give you a clue as to what this is. Next, we need to go to the Jello. Let's take a look at the Jello. Can you see the laser beam going through the Jello? If you can, that definitely means it's not a solution. So that might give you a clue as to what this is. It's certainly not a solution. Go ahead and label that one. And then lastly, vinegar. Vinegar is a mixture. It is a mixture. You got to decide whether it's homogeneous, heterogeneous, what it's made of. So this is vinegar. The appearance of vinegar. All right, next we're going to go ahead and try the Tyndall effect for each one of these things. And lastly, let's go to vinegar. Vinegar is a mixture. We'll turn this around so you can see a little bit better. And can you see the laser beam? Is it showing the Tyndall effect inside the water? I mean, sure, I can see redness, but I'm talking about like the laser beam going through the liquid itself. So that should give you a clue. Keep in mind, this is a mixture. It's actually water and acetic acid put together. So that might give you a little bit of a clue as to what this is. Once you've labeled all those things, take a look at the bottom of your lab. Notice it's asking what is a mixture, so you need to label, or you need to write out what is a mixture. You need to contrast heterogeneous and homogeneous mixtures. What's the difference between them? It's also asking you to Define a solution, a suspension, and a colloid. If you go up to the top of the page again, it kind of spells out some of the differences between a solution, a suspension, and a colloid. And if you scroll down a little bit further, I think you need to make a list of some things. Hold on. It says, how do you compare the particle size in a solution, suspension, and a colloid? So you need to write at least one full sentence, maybe two full sentences, how you would compare the particle size in each one of those things. And then it says, for each solution, identify the solute and the solvent. Well, let's go ahead and do this. Let's say for the first four. For the first four, identify the solute and the solvent. If you do all of them, it's going to take a long time, but do the first four, identify the solute and the solvent in the first four things that we had listed. So there's the sugar water, the starch water, the clay water, and the food coloring in the water. So identify the solute and the solvent in each one of those things. All right, have a great day, students.